Number 9 again. 178. 2 basics. We'll do several of these. And we just barely did one and we ran out of time. So this is going the other direction, right? So we've done a bunch of them where we start with the foreign base. Base 4, base 5, base 6, whatever. And go into normal. Go into base 10. Now we're going vice versa. We're going from regular to foreign. Aren't we? Going into base 6. So this direction's a little harder. Let me write some steps out to help. When going into a foreign base, not base 10, when you're going into a foreign base, first write the place value. So first you want to write out the place values. So I'm going to do that. And so let's do something. And it starts with the 1s, as you know. And then, so we're doing base 6, right? So remember how it works? You start with 1, you go times 6, times 6, times 6. So times 6 is 6, times 6 is 36. You can use calculator and everything. 216. Okay, write place values until larger than your number. See how 216 is larger than my number 178? So what you do when you're going into a foreign base system, it's a little harder. You write out the place value, start with 1, times 6, times 6, times 6. But how far do you go? Well, you go until you're larger than your number. You read my scribbles up there? I'm not writing very neatly. Until you're larger than your number, right? 216 is bigger than 178, huh? So I don't need any 216s. So cross that out. Step 2. So that's step 1. Write out the place values. Step 2. I'm probably going to need to move these. I'll move them in a minute. So step 2. Start at the largest place value and divide your number divided by the place value. So, and divide your number by the place value. Put that answer, maybe a little more clear. Put that answer in the place value spot. Put that answer in the place value spot. And how are you going to figure this? You got that many. Okay. Then multiply answer. And multiply answer times place value. Answer times place value. Subtract this from original number. Sounds confusing when it's all written out. It's not that bad. And then keep going. So get all that down, and then I'll show you practically, and it's much better than it sounds. And you do get a 3x5 card for the exam, so you could write all this down and keep going. All right, so there's the game plan, and I'll show you what we're talking about. It'll make more sense when we're actually doing it. So can you read all that? So step 1, when you're going into a foreign system, first write the place values until larger than your number. Start at the largest place value. Divide your number by the place value. Put that answer in the place value spot. Then multiply that answer times the place value. Subtract this from the original number. If you can see that there. And just keep going. All right. So what I'll do is I'll flash back and forth. So let's try. In fact, you probably got the top down. So how about I just leave the bottom for you to finish writing down, and I'll just work it up here. This will all be on YouTube later. If I'm going too fast for you, it's all on YouTube later. All right, so let's do it. So you start for step 1 is you write down the place values as we saw. So the 1, 6, 36, 216, that's too big, so forget that. So now step 2. So we did that's all step 1. Step number 2. Start at the largest place. That'll be here. Right? The largest one we're going to use. We're not going to use any 2/16. And divide your number by the place value. So let me give you the big feel, because feel is always better than particular steps. So the feel of it is we want to make 178 out of 36s, 6s, and 1s. You know what I mean? Hey, I grabbed the base 10 blocks before I came today. Let me show you. These are what I mentioned before, base 10 blocks. Maybe this would be a good time. So I'll let you. So how do we do it? So basically you start with the 36s and you say, how many of these do I need? I'm trying to make the number 178. How many 36s do I need? That requires division. You take 178 on your calculator, you divide by 36. Didn't somebody tell me the other day 4 point something, 4.9 or something? Is that what it was? Yeah, so I just keep the 4 because it doesn't quite make a fifth. So I can't use 5 36s because that'd be too much. That'd be 180, wouldn't it? So that's too much. So only 4 36s. That's all the 36s we can use. It comes out 4.9, whatever. You don't round it. You just use the whole number part. Because you can't use a full 5, so you just stick with 4. So 4 36s. So far, I've got 4 36s. Put that answer in the place. I did. Then multiply that answer by the place. Why? Well, because I want to know, how much is this? How much is 4 36s? Well, let me go figure that out. So 4 times 36, use your calculator, was that 144?
Yes.
That's 144. So when I write 4 in the 36s place, that's really representing 144, isn't it? It's 4 36s. So if that's representing 144, and my goal is to eventually represent the whole 178, how much do I have left to go? Well, you take I don't have any room left, over here. Take the 178 and subtract the 144 you've already represented. What do we got left? 34. That's what I'm saying down here. So, right? Subtract this from the original number. And then keep going. So we got 34 left to go. Is that making sense? So now we go to the next place value. Okay, I got 34 left to go. I've already got, 4 times 36 is already representing 144. I got 34 left to go. So how many 6s do I need? Yeah, if you just know off the top of your head, if you're rusty on some of those times tables, feel free to just use your calculator. So the formal thing would be 34 left to go. So take the 34 and just divide it by 6. You'll get 5, huh? Wait, am I doing the right thing? Yeah, you get 5 point whatever. Just use the 5. 5 6s is 30, as you know. So that represents 30, right? So how many more do I need now? Because I'm trying to do the 34. And then 4 more. There's the number. 454, base 6, this is a base 6 number, is the same as 178. It is 178. How could you double check it to make sure? What could you do? Multiply, and add them up, huh? It should total 178. What the number? That is 178. Make sense? Want to try? We'll do a lot of these. Is that good for the first one? That making sense on that? Yeah.
How did you get for the last one?
Yeah. So yeah. Let me kind of show the flow there. So we did the 436, which was 144. I had 34 left to go. After this, I had 34 left to go. Then I took that 34 and I divided by the next place value. Found out 5 of them was all I could take. 5. What is that? What is 5 times 6? It's 30, huh? So that represents, and I had 34 left to go. That used up 30, represented 30. So I didn't show it, but really I was subtracting the 30. 4 left to go. Good, I'm sure several people were wondering that. Thanks. Other questions I can answer? Is that good? All right, let's try the number 11. Change 52 to base 3. All right, let's give it a try. So try it on your own paper. All right, so first step, start with the ones place and go times 3, times 3, times 3. Right, we just start writing out place values. How far do we go? Till we're bigger than this number, huh? Another one would be 81. Boom, we don't need any 81s to make 52. So there we go. There's the first step. Keep going. So take 52 divided by 27. You get 1 point whatever, whatever. So it's just 1 there. Now, what's the next step? Do you know how to go from here? So remember, that's 127. So that's representing the number 27, isn't it? And we're trying to represent a whole 52. So that's already taken care of 27 for us. So we got to figure out how much is left. Right. What's that? Right, exactly. So you subtract the 27. Exactly. So 5, put a 4, put a 1. 25 left to go, huh? Let me write that a little neater. So keep going. So yeah, we take that original 52. Subtract 27. What was that again? 25 left. There's 25 left to go. So with the other digits, we've got to represent 25. There's 25. So this is what we started with. It was 52. 1 times 27 represents the 27. So next, yeah.
So when you get 25 left over, do you take 25 and then divide it by 9?
Exactly.
Okay.
Exactly. So that's the next step. So the next step, we're going to take 25, and we're going to say, well, how many 9s can we use for 29? For 25, yeah. And that's going to be 2 point something or other. So it's just 2. We're not rounding, we're just throwing away, you're just taking the whole number part, right? Throwing away the decimal. Just keeping the whole number part. Yeah, because we got 25 left to go, so we're saying, how many 9s is that? So how many times does 9 go into that? That's what dividing is, huh? Dividing is how many of these go in there. So 2. So, okay, so we got 2. Now, do you know the next step? Yeah, we got to multiply this. 18, yeah. 2 times 9 is 18. That's represent 2 in the 9's place is like, 2 rods or something, or 3 rods, right? That's how you want kids to say, look, this is 3 10s. It's not just 3, it's 3 10s. So this isn't just 2, it's 2 9s, huh? So 2 times 9 is 18. So that means we subtract 18. What does that give? 7? 7 left? 7 left? Keep going. 7 left. We go to the next spot. 3s. And we say 7 divided by 3. Because we're saying 7 are left to go. How many 3s can we use to make that? Comes out 2 whatever, whatever. 2 of those. By the way, look how the math naturally never gives us a 3 or bigger. Right? We're in base 3. We know there's not supposed to be a 3 or bigger. And the math just, why does that happen? It's because we started with the biggest. That's anything that would need a 3 or more was used in a higher level. It knows that. It automatically flows it down that way. So 2. So then 2 times 3 is 6. Bring that over. Only 1 left. So 1. There it is. 1221 base 3 is the same as 52. It's really 52. And you can double check it on your calculator on the exam. Just multiply, and add it up, huh? And it's 52. The total is 52. Question? Comment? 6. Oh, yeah. The 2 times 3. Yeah, good question. Just 1221 is our answer. Other comments or questions? Jesus. Yeah, so on the test, you would just write 1221. Yeah, before test day, I'll get you a practice exam, so you'll know the look of it. So I'll say, hey, it'll look like this. You'll just write in 1221. But yeah, that's generally the plan. It'll just be writing 1221. Yeah, I mean, base 3 would be nice. I'm not going to take off if you don't write the base 3. But technically, it's a base. We write that so we know it's not a base 10 number. It's not a normal number. I'm not going to take off if you forget that. But yeah, technically it's 1221 base 3. It's a base 3 number. That says 3. A little scribbly there. It's a base 3 number, not a normal base 10 number. 237. Change to base 5. Let's try now. This is the harder direction, so it's worth a little practice. So change that to base 5. So first step, write out those place values. So use your calculator, write out those place values. Hopefully you're getting that. Just you keep going until it's bigger than your number, right? So 625 is too big. We don't need any 625s to make 237. So we're going to start at the 125s place. There. So we get rid of the 625. Don't have any of those. So we start with the 237. And we divide by 125. Divide by 125, right? Because we're saying, how many 125s are in that number? How many 125s can we use to represent 237? So if you divide, don't you get one something, right? So it's just one. Good. So then, you want to think, okay, what is that? That's 1 times 125. So that means here's the 237 that I started with, and I'm going to subtract 125, leaves 112 left to go, huh? 112 left to go. So keep going from there, 112 left. Next, you're saying how many 25? So it's like money. How many quarters of $1.12? Yeah, we do money all the time, so we think better with money numbers, don't we? Because we do it all the time. So yeah, so I'm going to take that 112. I'm going to divide by 25 and get 4 something. Right? So basically we're representing $1.12 with quarters, nickels, and pennies. Using as many quarters as we can. That's what's left to do. So we know that's 4 quarters. And 4 quarters is $1. As you know, it's 100 cents. Subtract. 12 left, which we're going to do with nickels and pennies. Is this good? And then, so we take the 12 that are left, and we divide by 5, which is 2, something or other, 2 with a decimal remainder. So 2 nickels, which you know is 10. Subtract that, 2 left, the final 2. There it is. So the answer is 1422 base 5. 1422 base 5 is the same as 237. You can double check it on your calculator. If you just multiply, it'll come out. It'll go back to 237. It's getting easier. Seeming reasonable. Questions I can answer. We good? So again, if it's too fast, you can always watch on YouTube, slow it down. Although, where are we at? Number 13. 275 in base 12. It's always a little weird doing base 12 because that's the only base we regularly deal with that's higher than our base. That's higher than base 10. But it's the same game. It's exactly the same. It's just if you ever need a T, if you ever need a 10, you use T. And if you ever need an 11, you use E, right? When you're doing base 12, just remember, you might need a 10 in one spot. So you got to do it with one letter. You can't write 10. So you got to use T and E for 11. So give it a try, see if you can do the same exact thing. That's the right problem, isn't it? 275. All right, so we write out those place values. All right, so the place values, where do they start? Start with the ones, then times 12, and I don't even know what it is, but it's way too big. It's right, times 12. I know it's more than 275, right? So whatever it is, don't do it, right? So it's over 1,000, isn't it? So, so we start at the 144's place. So start there. So 275. See how many 144s go in? Just one, huh? One, almost two, but only one in the end. So 1. Keep going. $275 is what we started with. We're going to subtract. We good? It's making sense. Subtract the 144. So we get 131 left to go. 131 left to go. All right. So that next step's important. Let me let you do that if you haven't already. What are you doing? What do we do next? Good job. Because we go to the next place value, 12. So take what you got left, divide by the next. You're saying how many of the next place values, how many 12s will go into that, right? That divided by 12. Use your calculator. I think you're going to get 10 something, right? So that means 10. Now, I can't write 10 there. Why not? Why can't I write 10 there? It's got to be one digit. Remember, the same way kids will wonder when you're counting and they get up to 9 and they want to do 10. And all of a sudden, why do you need to write another thing? Why do you got to write two things? That same confusion here. Instead of 10 this way, we write T because it's just supposed to be one place. It's not two places, huh? We can't go 1-0. It's one place. So one character goes there. T represents 10 in the 12's place. All right? And next, what is that? Well, it's 10 times 12, huh? All right, 10 times 12. So bring it over here. This is 10 times 12. This is 120. Right? It's 10 is the face value in the 12's place. So 10 times 12, 120. So then, subtract that. 11 left. And you got to put an E there, don't you? Because that represents 11. Again, it's only one place. We can't put 1. There's not two places there. And so there we go. 1TE base 12 is our answer. How are we doing? Is that good? Questions on that one? Let's do one or two back on the easy way. So that's all the hard ways. That's all the ones going into foreign in the homework. If you're good there. All right. So, number 10, part C. 2,4E base 12, 2 base 10. So now, this is what we were doing Monday. This is the normal direction now. Right? Because now we're starting with the foreign system, aren't we? So what I noticed over my years of teaching, even though it's my first time here, I taught these classes at Stanislaus State, as I mentioned, for 10 years. What I noticed in these kinds of problems that confuses students is they're not sure where to write the 12 place values. That's what I've noticed. That's what they've always said to me over the years. They'll go, Mr. Aaron, I don't know. I get confused. Am I supposed to come over here and do the 112, 144, the 12 place values? Or do I do them right here? Like, how do you know where to do them? Because, we have the two different directions and it gets confusing. So what I learned to point out to students is basically you write those wherever the foreign word is. So where's the weird word, the 12? Whoops, I'm erasing it. I don't mean to erase it. It was right there. Hold on. Let me put it back. It's right there, right? So that means I'm going to write the foreign numbers right here. The 1, the 12, and then times 12 is 144. It goes right there rather than on the side. Let me compare. Let's go back. See this one? On this one, the one we just finished, number 13, where's the foreign words? Over on the side, huh? So I wrote the base 12 stuff over on the side, not under this number, because he's a normal number, huh? Don't put this 12 stuff under him. Does that make sense? So wherever you see the foreign number system, that's where you put the foreign place value. So if the 12 is on the side, put the 12s over here on the side. If the 12 is right there on your number, then that is a base 12 number. So put the base 12 place values right there on that number. All right, can you take it from there? So what do we do? Let me do this one with you. What do we do then? Just multiply them, right? We good? You just say 244. Just like for kids, 234. You're gonna teach kids this is 200s, kids. It's two of these, and it's 3 tens, right? 2 times 100, right? That's how you would figure this out. This is 234, and then you add them up to get 234, right? It's 200, right? You multiply, multiply, multiply. That's how any place value system works. So it's the same thing here. 2 times 144. And 4 times 12. And this is 11, huh? 11 times 1. So boom, boom, boom on your calculator. What's that? 288 plus 48. I'm getting scribbly there. 48 plus 11. I could do that in my head, but I hate to show off. So I'll let you tell me. Yeah. What is it? 347. I was just kidding. All right. We good there? Is that making sense? So you see where the two different directions and where you write the foreign place values, wherever the foreign word is. So if the 12 is right on the number, write them right there. Multiply, multiply, multiply. And if it's on the side, like in the last problem, then you put them on the side. That's the harder way. We got to do the divide thing and all that. Good. Is that making sense on that?